Hello Year 9s and welcome back to Mathematics. In today's lesson we're continuing our topic of indices and surds. And what we're looking at today is actually extending the power of a power law that we looked at in the last video. So in today's lesson our learning intention is to understand and apply index laws as we did in the last two lessons. And in particular today we're going to be applying the index law for powers of products and quotients and simplifying expressions with combined index laws. Now from the last lesson, what we did was we looked at what happened if you took a power of a power. So for example, if I had a to the power m, and then I raised that to a power n, so we took a power, m, and then we took that to another power, n, what we noticed was that this actually became a to the power m times n, or a to the power mn. And so what we did was we multiplied the powers. What we're going to be doing today is we're looking at what happens if we actually use the power of a power rule with products and quotients. So what happens if we raise two things that are multiplying together to a power, and what happens if we're dividing two terms together to a power. So here, that's what we have here. So when multiplied or divided terms are raised to a power, raise each term by the power. So what this looks like is if you have a product, so if we're multiplying two terms together inside a bracket and it's being raised to a power, or if we've got a division, so a quotient where we're dividing, so here for the second example we've got as a fraction and we're raising that to a power, what happens? And so for the first one I've also rewritten in algebraic in an algebra form. When we do a times b, we don't write the time symbol, so here in the first one it's just ab to the power n. What happens here is we raise each term to the power individually. So what this looks like is I have a to the power m times b to the power m. So we raise each term individually and we still multiply it together, or in the case of division, we do a to the power m divided by b to the power m. So what we do when we have multiplied or divided terms being raised to a power, we raise each individual term to the power and we keep that multiplication or division still there depending on what we're given. Okay, so let's apply this new index law. So here, using power of a power with products, we're going to start off by looking at products first. So here, what we want to do is we want to expand each of the following. So the additional, actually, let's go through it. Let's have a look at the first one. We've got 5b. Now 5b, that's just writing 5 times b, or to the power 3. So here what I'm going to do when I'm expanding this, I'm just going to raise the 5 to a power 3 and the b to the power 3. So here this is just going to be 5 to the power 3, b to the power 3. And that's it. Now, in algebra, or when we're dealing with these indices, particularly when you've got a number being raised to a power, we can actually find what that value is and write it down. So here, instead of writing it as 5 to the power 3, we can actually figure out what 5 to the power 3 is. And so that's just 125. So we can write this as 125 times b cubed. Now b we don't know, so we can't actually simplify that any further. So when you've got numerical terms raised to a power, you can actually figure out what the value is. And that's what we talked about in the first lesson, how when you've got index form, you've also got numerical values when you're dealing with numbers in particular, proper actual numbers as opposed to pronumerals in particular. Let's have a look at the next example. Now this time, I've got negative 2x cubed y to the power 4. So we're raising the whole term, negative 2x cubed y to the power 4. So when we do that, we're going to raise each of the terms individually to the power 4. Now, I'm going to make an important note here. This negative, I'm going to actually include it as part of the 2. When you've got a negative sign, we're going to include it with the number. So here, this becomes negative 2 to the power 4, x cubed to the power 4, and y to the power 4. So I'm raising each individual term to the power 4. Okay, now, as I said, what we can do is we can evaluate numbers. So here, what we can do is we can chuck in, so I'm going to put this in brackets because the brackets are really important here, negative 2 to the power 4. Negative 2 to the power 4 is 16. Now, be really careful here when you're dealing with numbers. That negative sign is part of that number. So you need to make sure that you include that bracket. Because if you don't, have a look at what happens here. I get negative 16, and that's not quite the same thing. So the negative needs to be part of that bracket. So here we've got 16. Now, when you've got a power of a power, just like we have here, so we've got x cubed, and we're raising that to a power 4. just like we did last lesson, we multiply the powers. So here, this becomes x to the power 3 times 4, which is 12. And the last term, y to the power 4. And we keep it there. Cool. So just again, like we did when we're doing raising products to a power, we raise each individual part of our product. So the -2, x cubed, the y, to the power 4. Okay, let's have a look at this last one. So here we've got 4 times, bracket, c squared d to the power 3, all to the power 5. And so just like we did in the last two, we're just going to raise each of the individual terms I'm raising a power to using that power product rule. So here, I'm going to leave that 4 at the front. So it's going to be 4 times c squared to the power 5. Well, actually, we don't need to write that times. I can just write this as c squared to the power 5. So I'm raising c squared to the power 5. I'm doing that first part. And I've also got d cubed to the power 5 as well. Okay, and when we've got a power of power, like we did last lesson, we multiply those indices. So here this becomes 4c, 2 times 5 gives me 10, c to the power 10, d, 3 times 5 gives me 15, d to the power 15. And there we go. So that's how we can actually evaluate and simplify expressions where you've got products to the power. What we want to do is we want to we want to raise each individual term, each individual section by that power that we're raising by. So here we did that for each one. And particularly the other thing that we noticed was if you've got numbers that are being raised to a power, we can actually evaluate what that value is. And so, for example, for the first one, we found that 5 cubed was 125. And the second one, -2 to the power 4 is actually 16. Okay, so that's when we're dealing with products. We're also going to be looking at quotients. So what happens when we do division here? So using the power of a power with division. So simplify each of the following. Just like we did before, we're going to be raising each of the terms to the power that we have on the outside. But we just want to make sure that we put them in the right spot. If they're in the numerator, we keep them in the numerator. If they're in the denominator, we keep them in the denominator. Okay, so let's have a look at the first one. I've got 6 over b all to the power 3. So just like we did before, we're going to raise each of the terms to that power separately and keeping them in the same correct spot. So we've got 6 in the numerator, so that becomes 6 cubed. Great. And at the bottom, we've got b over b cubed. And like, as I said, 6 cubed, we can actually evaluate what that is. I think that's 216, but we can check that with a calculator. 6 cubed, 216. Excellent. So we can write this as, wrong pen, 216 over b cubed. So here that is 216 over b cubed. Excellent. So just like we did before with our products, this time when we're dealing with our quotients, we just do the same thing. We raise each of our terms to that power and leave them in the numerator and the denominator separately. Let's have a look at the next example. The next one actually combines what we looked at in the last section with the products with that division. So here we've got -2a squared over 3bc squared. Notice in both the numerator and the denominator, we've actually got a product. So for example, here we've got actually -2 times a squared. And in our denominator, we've got 3 times b times c squared. So what we're going to do is we're going to combine both of those rules that we looked at in today's lesson all in one. So when I'm doing this, I'm just going to raise the numerator to the power 4 and the denominator to the power 4. So here this becomes -2a squared to the power 4 over 3bc squared to the power 4. And just like we did in the last part, when we've got a product being raised to the power, we're going to raise each of those terms to that power. So here for my numerator, this becomes -2. I'm going to include the negative part of the 2 to the power 4, a squared to the power 4. And that's all over 3 to the power 4, b to the power 4, and c squared to the power 4. Okay, and so now we can start to evaluate a few of the things. So first of all, I'm going to evaluate the numbers. So here I've got -2 to the power 4. Now in the previous example, we actually did -2 to the power 4, and we found that that was 16. And then in the other term in my numerator is a squared to the power 4. And so when we have a power of a power, we multiply the powers together. So here I get a squared times a to the power 2 times 4. So that's a to the power 8 over. In the bottom, I've got 3 to the power 4. We can evaluate 3 to the power 4. Now, I think that's 81, but we can check that with our calculator. 3 to the power 4, 81. Excellent. So here, this becomes 81 got b to the power 4. And the last term, c squared to the power 4, power over power. We multiply the powers together. So it's 2 times 4 gives me 8, c to the power 8. And so that's how we can simplify this expression here. So this one, we actually involved a few more steps because we had to apply the power of not only the division part, but also needed to apply the product part, power of a power. Okay, let's have a look at the last example here. Now for this one, we've got two fractions that are multiplying together, and we're doing powers of power for both of them. What we're going to do is we're going to deal with each of the fractions separately and then deal with the multiplication, this multiplication at the end. So deal with the brackets first and then work towards that multiplication. So using that same using that same quotient, extended power of a power rule with our quotients, we need to raise each of our terms in our numerator and our denominator to the power, and that's on the outside. So for example, this first fraction, we've got x squared y cubed over c to the power 3. So I'm going to raise the whole top, so the numerator to the power 3. So I've got x squared y cubed to the power 3 over c to the power 3. Okay, cool. I'm going to do the exact same thing with my second fraction, but instead of power 3, it's going to be power 4 this time. So it's xc to the power 4 over y to the power 4. Okay, now I've got a few more brackets. I've got to deal with the first one here. So that's x squared y cubed to the power 3. I raise each of my terms individually to that power. So I use that power of a power. So I've got x squared to the power 3, y cubed to the power 3. Oh, let me write that a little bit clearer. And I've got c cubed down here. And over on the other side, I've got xc to the power 4. I raise each of those products terms inside to the power 4. So I've got x to the power 4, c to the power 4 over y to the power 4. Okay, cool. Still got one more set of brackets. Let me just deal with those. So when you've got power over power, you multiply the powers together. So here you get x to the power 6, y to the power 9 over c cubed times x to the power 4, c to the power 4 over y squared. So here we got that 6 by doing 2 times 3, and I got that 9 by doing 3 times 3. Okay, now that we've done that, what we've got here is we're multiplying two algebraic fractions together. Now, I'm not sure if you remember from earlier this year, but when we multiply algebraic fractions, what we want to do is look for common factors in opposite numerators and denominators that we can cancel out from each other. So if you have a look over here, I've got c cubed. And on the other fraction, in my numerator, I've got c to the power 4. And so what I can do is I can actually cancel out c cubed, and just like we would normally do when we do division, when I do c cubed, c to the power 4 divided by c to the power 3, we minus the power. And so here I'm left with c to the power 1, or just c. And using that same pattern, if you have a look over here, I've got y to the power 4 and y to the power 9. So opposite in my numerator and my denominator, they're opposite here. And so like we normally would, I'm just going to divide. I'm going to cancel out c to the power 4 and divide it from c to the power 9. Now when you do division, you subtract the powers, so you're left with 9 minus 4 is 5. And so the final answer, we're just going to multiply what we have left over together. So here I've got x to the power 6, y to the power 5 times x to the power 4, c. And so when we multiply, we look for the common indices, common bases, and we multiply. When we multiply, we add that powers. So here, if you have a look, I've got an x to the power 6 and x to the power 4, and when we multiply, we add the powers together. So here I'm going to get x to the power 10, and for the other terms, we have no other common bases, so we just write what's left over. And there we go. So that's how we can simplify expressions where we've got power of power with division. Okay, so that's it for today's lesson. Let's just do a quick recap of what we did today. In today's lesson, we actually extended the power of a power rule to look at what happens when we raise a product, so when we multiply to a power, and a quotient when we divide to a power as well. And so what we notice is that when we raise a product or a quotient to a power, we raise each of the individual terms in each of the individual factors or the numerator and the denominators separately to that power that we have on the outside. So we went through a couple of examples of how we did this with products, and what we noted that was that when you have a numerical value, so for example 5 or -2, we can raise that to a power and find what that value is. And we also did that with division, and we actually noticed that there was a few trickier examples where we gonna need to combine some of those other index laws that we looked at. So that's it for today's lesson, Year 9s. Hopefully that was helpful. And if you have any questions, feel free to ask or send me a message via Google Classroom or email. I'm more than happy to try and answer your questions. But that's it for today's lesson. I hope you guys are staying safe wherever you are. And I'll see you in the next video. Bye.